information.
Good morning, Lina. Yes, sir. Good morning, sir.
I would like to invite you all.
Hi, Professor Namanaja. Hi, how are you? Thanks for your invitation. Appreciate it.
I think Sinha sir has got login.
Yes, I am here.
Yes, sir. I think.
Good morning.
Yeah, good morning, sir. Good morning. Good morning. I think it is already done. Then we can start the program. I think Madam Soumya.
Sir.
I think you can start the program. What
Yes,
is the time now? It is already written, no? Fine.
Yes, sir. Yes, sir. Okay, sir.
Yeah, please. Maybe I would like to see one minute, please.
Ramaraju, sir, can we start the program? Sir, Ramaraju, sir.
One minute. She knows somebody and got a second line. My head message.
Wendy.
Like an sir. Please, like please. Yeah. Good morning, young sir. Good morning.
Good morning.
Good morning. Sir, what is the time now at Australia now? What is the time?
My time at Australia now is 2:35 afternoon.
Oh, fine.
Yeah.
Yeah. I think you could have seen our. Sir, like sir. Like
Start.
Yeah, we can start the program. I think, Madam Soumya, you can easily start the program. Soumya, you can start the program, please.
Yes, sir. A very good morning to one and all. I'm Dr. Soumya. I feel privileged to welcome the delegates and participants on behalf of our institution to the celebration of World Environment Day 2022, jointly organized by the Department of Civil Engineering, Dayananda Sagar College of Engineering, and Indian Waterworks Association. I wish you all a happy World Environment Day. On June 5th every year, we commemorate World Environment Day to spread awareness about conserving our nature, as well as burning issues such as climate change, water pollution, air pollution, overpopulation, and so on, and every other issue affecting our environment. Indian Waterworks Association was established in 1968. It is a voluntary body of concerned professionals having more than 54 years of meaningful and strong existence across India. with its headquarters at Mumbai and 34 centers spread all across the country, IVA connects more than 12,000 plus professionals from different sectorial groups. IVA mainly focus on water supply and issues related to it for municipal, industrial, agricultural users and treatments and disposal of wastewater spread all over the country. IVA mainly focuses on entire water cycle encompassing the environmental, social, institutional, and financial issues. With this brief introduction about IVA, so I would like to start the program. So today's World Environment Day theme focus on only one Earth. Environment is most important for all living beings. Without a suitable environment, life is impossible on Earth. As it is so important for us, we have to protect this, and for this, we are observing World Environment Day every year to spread awareness about the environment. Now, we begin this program with invocation song by Ms. Sri Raksha of 6th semester. Sri Raksha, over to you.
जयतु मंगलमूर्ति गणपति हरसु बारै अनुदिना हरसु बारै अनुदिना जयतु मंगलमूर्ति गणपति हरसु बारै अनुदिना हरसु बारै अनुदिना आदि गणपति वेद मूर्ति परम पावन चरितने आदि गणपति वेद मूर्ति परम पावन चरितने जयतु मंगल मूर्ति गणपति हरसु बारै अनुदिना हरसु बारै अनुदिना वरुषक्ಕೊಮ್ಮೆ ಬರುವೆಯಾದರೂ ನಿತ್ಯ ಪೂಜೆಯಗೊಳ್ಳುವೆಯ ಜಯತು ಮಂಗಳ ಮೂರ್ತಿ ಗಣಪತಿ ಹರಸು ಬಾರೈ ಅನುದಿನ हरसु बारै अनुदिना. Thank you.
It was melodious song, Sri Raksha. Thank you. Now I welcome Dr. H.K. Ramaraju sir, Professor and Head of Civil Engineering Department, DSCE, to deliver the welcome address.
Good morning to all. The World Environment Day 2022 with a theme, only one earth for anybody, only one mother. Like that, it is only one earth, the mother earth. The whole, a broad word, what exactly we are going to tell is the mother earth, where all the biotic and abiotic components in the biosphere are all the parts of the environment. Generally, environment means hasiru, that green. There is a poem from our Kuempu, is a Gnanapita Awardee, where hasaru, that is green, which is in Halagannada. Just I would like to tell in this international conference, where which clearly reflects ಹಸುರತ್ತಲ್ ಹಸುರಿತ್ತಲ್ ಹಸುರೆತ್ತಲ್ ಕಡಲಿನಲ್ಲಿ ಹಸುರ್ಗುಟ್ಟಿತೋ ಕವಿಯಾತ್ಮಂ ಹಸುರ್ನೆತ್ತಲ್ ಒಡಲಿನಲ್ಲಿ. The summation is green here, green there. An ocean of green everywhere. Green flows the blood in the poet's vein, and a blazing green has stirred his soul, which clearly reflects how exactly we are interlinked with our environment in the local atmosphere, that is in the biosphere, in the day-to-day activities. Friends, our natural capital, air, water, land, biodiversity, and ecosystem is continually being encroached upon. And there is an urgent need to protect our heritage and traditions that are under threat. Managing the activities of the people in a way that conserves the habitats and resources, and at the same time protects and promotes the development is extremely complex and difficult. To ensure sustainability, there is a need to integrate the environmental concerns with the social and developmental concerns. Friends, Indian Waterworks Association, a well-known organization in India, which was established in 1868. We are closely working with that organization. I, as a director of international, we are conducting so many programs, specifically in the water sector, water, wastewater treatment, again, the environment. When we tell the water is life, sanitation is a way of life. Millions of people in the world lack safe accessibility of drinking water and basic sanitation facilities, which are essential to human health and well-being, where the Indian Waterworks Association is closely working with the environmental engineers, water resource engineers, and all the people who dedicate themselves to protect the environment. At the same time, I would like to bring out certain things here. Dr. DBG or Mankutimana Kagga, which is called almost Kannada Bhagavad Gita, it is a Bhagavad Gita in Karnataka, in Kannada, what I can tell. There are a few sentences. Prakruti and Avarata, Manuja, Tidutirvante, Vikruta Godisonum, Ake Yangala, Bo Kushika, Rasa Tantri, Shilpi, Wahana Yantri, Vakuchis Renavala Mankuti. Still continuation to that one, there is a reason. How do? ಹೊಸ ತನವೇ ಬಾಳು ಹಳಸಿಕೆಯಲ್ಲ ಸಾವು ಬಿಡು ಹೊಸ ತನವು ನವನವತೆಯಿಂದ ಅನುದಿನವು ಹೊಮ್ಮಿ ಹಸನೊಂದು ನುಡಿಯಲ್ಲಿ ನಡೆಯಲ್ಲಿ ನೋಟದಲ್ಲಿ ಪಸರುತ್ತಿರೆ ಬಾಳ್ ಚೆಲುವು ಮಂಕುತಿಮ್ಮ. ಸಿ ಮದರ್ ಅರ್ತ್, ಇಟ್ ಪ್ರೊವೈಡ್ಸ್ ಎನಫ್ ಟು ಸ್ಯಾಟಿಸ್ಫೈ ದ ಎವರಿ ಮ್ಯಾನ್ಸ್ ನೀಡ್ ಬಟ್ ನಾಟ್ ಎವರಿ ಮ್ಯಾನ್ಸ್ ಗ್ರೀಡ್. ಇನ್ ದ ನೇಮ್ ಆಫ್ ಇಂಡಸ್ಟ್ರಿಯಲೈಸೇಷನ್, urbanization, population growth, technology development, so many changes have been taken place. In spite of technology development, shortage of even raw materials in the environment, so many changes are taking place. Friends, this is the program where we invited, requested so many experts from the outside the country also. They agreed for our request, and they are going to deliver the talks. Today's function is actually graced by, first of all, I would like to call our the eminent and very hardworking, the chair president of our Indian Waterworks Association is this, P.K. Sinha sir, who was a former chief engineer in UP. Sir, I wholeheartedly welcome you to this virtual conference. Sir. It is a cordial welcome to you on behalf of our Dayananda Sagar College of Engineering and IVA. I invite you to grace the occasion, please. Dr. Sinha, please. Then, similarly, here, the major thing is specifically in the organization. When you take our locally Indian Waterworks Association, we are located in Bangalore. Our local chairman, Srinivas Reddy Sahab, is here. He is also a very dynamic person who is cooperative in all our activities. I welcome Srinivas Reddy Sahab, who is a philanthropist, basically working in several Ramanashya Ashram and several activities. He is working towards to save the environment and to save the public, to help the public and all. I welcome him for today's conference, for this virtual conference. Our principal, Dayananda Sagar College of Engineering, Dr. C.P.S. Prakash, who is behind all our programs, who helps us conduct the programs. I wholeheartedly welcome our principal, Dr. C.P.S. Prakash, to this virtual conference. At the same time, as I already told, there are other senior professors from Dayananda Sagar College of Engineering, even along with me, Dr. G.P. Shivshankar is here, Dr. Shivkumar is here, and I have seen so many professors from different parts of the country. They are all already present here. and the members of IWA, Indian Water Works Association. And I think 4 or 6 delegates from our, even I think Malaysia, there are 2 people are entered, I mean, they are logged into the conference. At the same time from Singapore, totally almost 68 international delegates are also present here. I welcome all the delegates, even I welcome the media presence, because finally that should reach the media and disseminate the matter to the public and all. So I should that majorly now I would like to go to the our secretary is here, our IWA local, our Bangalore secretary, Shri Renukumar sir is also here. Sir, I welcome you for the today's in this virtual conference. More than that, today's the stalwarts are our speakers. Our speakers, Dr. Xiu Qingyang is from basically from University of Wollongong. He is a professor in water resource engineering. He is majorly working on specifically coastal reservoirs, and he has written a book and is a very strong man in the water resource engineering and very good publications and all. Very strong man. He visited our college also. Even when I went to University of Wollongong, I met him. He is a very strong man in the field. Keeping that, I requested him. He's agreed to deliver a talk. Sir, I wholeheartedly welcome you, Yang sir, please, for today's conference, please. At the same time, our close associate, our Dr. Leena Shivade, who was earlier the faculty at our Dayanand Sagar College of Engineering. Now she is in US with Lafayette University, Peninsula. Because I had a interaction with Leena, she told that no sir, no problem. I can easily deliver a talk specifically related to environment and all. And is a very, since he's closely working with us, it was my pleasure to invite Dr. Leena also. Leena, I wholeheartedly welcome you today for this virtual conference. At the same time,
Thank you, my pleasure.
Thank you. At the same time, our another good friend, Mr. Amrit Paul Sagu, who is the head of School of Architecture and Built Environment, Nottingham, Trent University, United Kingdom. He just evening also he gave me the call. He is little bit has a health issue problem or not. He may join in the middle. He told that Ramaraju, you just go ahead with the program. I will join at the end. That was exactly he indicated. Anyway, I welcome him for today's the virtual conference. So once again, I welcome all the delegates, our students, our Dayanand Sagar College of Engineering, and so many students from engineering colleges like VTU, Visvesvaraya Technological University, and other from different parts of the country. Almost nearly now the strength is almost nearly 432 strength they have entered. Of course, here only in our link only 300 can be entered. We have YouTube link is also been created. Almost majority of the students are entering. I mean, other members, participants, they are entering. I welcome all Indian Water Works Association, the members, and IPH, Institution of Public Health Engineers. It is a part of our organization bank in India, and all other members. Our specifically some of the official bodies of our Indian Water Works Association, and from the various departments, even rural development, Panchayat Raj, Public Engineering Department, Water Source Department. Almost majority I can easily see here. So many delegates are there from different parts of the country and different parts of the world. Even some of the NGOs and students, researchers. I welcome one and all, even the media, the press and media. I welcome one and all to this virtual conference. Thank you all. Thank you all. Over to Soumya, please. Dr. Soumya, please.
Thank you, Ramaraju sir, for delivering the welcome address. Now we shall begin the program with an auspicious virtual lamp lighting ceremony. So I request Chetan sir to start the video of lamp lighting.
Kalyanam Arogyam Dhanasampada Shubham Kurutvam Kalyanam Arogyam Dhanasampada Shatru Buddhi Vinashaya Deepajyotir Namostute Deepajyotir Namostute Deepajyotir Parabrahma Deepajyotir Janardana Deepajyotir Parabrahma Deepajyotir Janardana Deepo Hartu Me Papam Sandhya Deepa Namostute O Deepa Brahma Rupasvam Jyotisham Prabhuravyayah बुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः
Welcome back. Now let us take a glimpse of our esteemed institution, Dayananda Sagar College of Engineering and Civil Engineering Department with a short video.
Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way.
They will get to know by our email. Email after the number. About another email.
Be what you want, who you want, when you want to be. Do something, feel something that will always set you free. Now it's time to pull out the curtain. Show them all that you're make them see that life's a beautiful symphony. Seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Joining hands makes your journey easy. Sharing smiles makes your road so breezy. Looking out, don't you see your future? Finding out, breaking billion boundaries. Oh, yeah. Joining hands makes your journey easy. Sharing smiles makes your road so breezy. Looking out, don't you see your future? Finding out, breaking billion boundaries. Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Live the dream, seize the time, seize the day, make your way. Yes, I.
Namaskara. Civil engineering is known as the mother of all branches of engineering. It is a broad discipline that identifies the specializations like environmental engineering, water resource engineering, structural engineering, pre-stressed concrete, construction technology and management, highway engineering, geotechnical engineering, and architecture and town planning. The Department of Civil Engineering started in 1979 with an intake of 60. Now we have an intake of 180 with 2 PG programs, structural engineering and highway technology. We have accredited to NBA from 2005. We have well-equipped laboratories. As you are aware, civil engineering profession involves planning, analysis, design, construction and maintenance of different types of structures for government and private sectors. These include high-rise buildings, schools, colleges, airports, dams, harbors, tunnels, all these. At the same time, civil engineers also plays a dominant role in wastewater management, solid waste management, biomedical waste, electronics waste. Civil engineers keenly observe and identifies the problems faced by the society and also develops appropriate solutions based on technical feasibility, economics and sustainability. Civil engineers are creative and yet practical. We have well-developed consultancy cell working closely with the Ministry of Rural Development and Panchayat Raj, Ministry of Water Resources Department. Visit our college, department. Our research and development reflects what we are.
To facilitate the academics, consultancy, and research, the department houses state-of-the-art laboratories and computer facilities. All laboratories are equipped with modern testing equipments and latest design software to meet the curriculum and present industrial requirements. KIOCL Center of Excellence Lab provide researchers facilities to conduct research on solid waste generated by industries. Department is having Sukritya Students Club, which is actively functioning in the field of technical, cultural, societal, sports, and other extracurricular activities. Under this club, Swachh Bharat program is organized every year in and outside Bangalore, emphasizing on clean and sustainable environment. Department is having professional body memberships with renowned professional bodies of India. Technical fest, conference, workshop, and symposium will be organized every semester in association with major funding agencies of India. trips and hands-on learning make concepts more memorable. Our branch that is more related to fieldworks have ensured to give the students exposure by organizing field visits to various places such as water treatment plants, construction sites, irrigation and dam sites, etc. Also, extensive survey camp is a part of the curriculum for the students of 6th semester. Every year, the camp is conducted for a duration of 10 days at Melukote in Pandavapura Taluk of Mandya district, Karnataka. Around 4,000 engineers have graduated from the department since 1979. The alumni of the department are a part of national and international projects and many are leading entrepreneurs. To name a few, our alumni are rendering their service in Indian defense, Indian administration, politics, arts, sports, research and academics. Welcome back. Now I request all the dignitaries to turn on the video to take the screenshot.
I think Dr. Yang sir and Dr. CPS sir and Ren Kumar sir is already entered.
Srinivas Reddy sir.
Srinivas Reddy sir. Amrit.
Redu Kumar sir. Redu Kumar sir.
Yeah, he is entered. Sure, Yang sir.
Dr. Young, could you please turn on your video?
You asked me
Thank you,
to
sir.
do the presentation now?
Yeah.
Thank you, sir.
Yes.
Okay. Okay, great.
You can have a photograph, I think. Yeah.
All right. I can share my screen.
So, hey, sir. Hello.
Can you see my screen? Can you see the?
Yes.
All right.
Yeah.
Okay, thank you,
no.
Professor. Yeah, can you see my screen?
1 minute, 1 minute, sir. And now actually, your technical talk will be taken later. Now, Soumya, you can easily proceed with your programs.
Yes,
We requested you to on the videos to have the glimpses of photos. That is all. Your talk will be there another half an hour. 30 minutes after that, your talk will. I think we request you to deliver the talk. Now, other programs is there. I think Soumya, you just start the anchoring other activities, please.
Yes, sir.
Yeah, please. Yeah.
Dr. Young, sir, by another 20 to 25 minutes, you'll be invited to deliver the talk.
Yeah, thank you. So, what is you asked me to do now? You asked me to give the talk.
Now we will have the inaugural address, sir. After that, we will start the technical talk.
All right.
Okay, sir. Thank you, sir. Now I invite our honorable guest, Shri P.K. Sinha, sir, President of Indian Waterworks Association, to deliver the inaugural address. Sinha, sir.
Good morning to everyone. Am I audible?
Yes, sir, you're audible.
Respected Reddy sir, Chairman, Bengaluru Center, Indian Waterworks Association, who is our real guide, Dr. Prakash, Principal, Dayanand Sagar College of Engineering, Dr. Ramaraju and Engineer Renu Kumar of IWWA, means IWA, our honorable speakers from Australia, UK, and USA, and all other participants with us from different locations. At the outset, I would congratulate Honorable Principal Dayanand Sagar, College of Engineering, Bengaluru, for organizing this program jointly with Indian Waterworks Association. I am really thankful. I am really thankful to organizers for giving me opportunity to be with you all on this occasion. For those who do not know, the objective of IWWA is to stimulate and promote the development of science, technology, economics, environment, ecology, and social sciences in managing the water, both fresh and wastewater. Water being an essential component of environment, we are well concerned with what environment. IWA provides a common platform for persons and organizations working in this sector to exchange views, share ideas, disseminate information and knowledge about new and appropriate technologies for improving and upgrading the services. In pursuit of its aim and objective, program on World Environment Day is being organized by IWA throughout India by its centers. On 5th June 1972, I think our learned speakers will enlighten about the theme and the other issues related to the environment. But as a ceremonial requirement, I would like to touch upon the theme. On 5 June 1972, the very first conference at international level communicating environmental issues was conducted by United Nations Conference on Human Environment at Stockholm. Attended by 114 countries, this conference declared 26 principles recognizing the human impact on environment publicly and global scale. This conference tried to find a way to tackle the air, land, and water pollution by working together as a unit, as one unit, to safeguard the human environment for a better tomorrow. The main purpose was to save the earth, and the slogan was only one earth. The declaration of conference urged every country to create regulations for protecting wildlife and natural resources and that are available in that country and have a national population policy. The purpose of this conference was to create awareness among nations and their citizens. India was represented by then Prime Minister, Mrs. Indira Gandhi, who addressed this conference, showing the importance to the environment. It is necessary to mention that only 2 countries out of 114 were represented by the prime ministers. India has shown its sincerity regarding environment after the Stockholm Conference 1972 and brought major changes in its legal framework. Another significant development was the establishment of pollution control boards and broadening of its scope. Indian courts have also tried to protect the environment through PILs. India is one of among 3 nations who have established National Green Tribunal all over the world. Now 50 years have passed, and again the host country of World Environment Day is Sweden. And the slogan is again only one earth. Now it is high time to evaluate the overall position of environment on the entire globe. We all know that whatever the biological resources the entire humanity consume in a year, the ecosystem of Earth should generate it in the entire year to keep the environment intact. If we consume more than the Earth regeneration capacity, we will need another Earth, which we do not have. The past 50 years have seen fast development in the developed and developing countries. The luxuries adopted by the developed world, leading to heavy consumptions of resources, has ultimately led to depletion of natural resources and increased pollution, global warming, climate change. Global Footprint Network is an environmental research organization who evaluates Earth Overshoot Day every year based on collected data from all over the world. Earth Overshoot Day is the date when humanity will have used all the biological resources that Earth can renew during the entire year. In 2021, the Earth Overshoot Day was 29th July. It means at present, we require 1.7 Earths, but we really have only one Earth. We maintain this deficit by liquidating stock of ecological resources and accumulating waste, primarily carbon dioxide in the atmosphere. It makes us think about our environmental footprints. It reminds us to amend ourselves because we have only one Earth. If we observe the data for Earth Overshoot Days of previous 3 years, the overshoot date was 26 July in 2019, 22nd August in 2020, and 2021, 29 July. In the year 2020, it is 3 weeks later than 2019 date, reflecting a 9.3% reduction in humanity's consumption of our world biological resources. This is important to understand. It was not because we got better deliberately due to our effort. It was because of coronavirus-induced lockdowns around the world. The worldwide lockdown brought the decrease in forest cutting, carbon dioxide emissions, stoppage of vehicles, aeroplanes, marine ships, and work from home. They were the major drivers behind the historic shift in ever-growing humanity's ecological footprint. Earth Overshoot Day is being assessed since 2006, when it fell in October. Since then, the date steadily shifted earlier, almost every year until 2020, when the COVID-19 pandemic improved the environment. But at what cost? At the cost of world economy and millions human lives. The inference can be drawn that with the focused and designed effort, things can be managed. The Global Footprint Network makes these calculations by country as well as globally. For instance, according to a report, if the whole world consumed like United States, we would have hit Overshoot Day in the March. Means if we would live like Americans, we will require 5 Earths. The similar is with European and many Western countries. It is satisfying that India still spends biological resources which is generated in the year. If the world lived like Indians, only 0.7 Earth is required. But India is a fast-growing economy, aspiring to touch $5 trillion US. India's economic growth is also necessary for eliminating poverty with a considerable section of society. Therefore, a balance between growing scarcity of natural resources that are essential for sustaining further growth and eliminating poverty with economic growth is to be maintained. India is aggressively focusing on solar energy, afforestation, river pollution abatement programs, solid waste management, and many more measures to reduce the environmental footprints. The developed countries have to be more responsible as they are major contributors of environmental footprints. At the end, I would say the message is very clear. We will have to keep improving our relationship with nature, understanding its value and putting that value at the heart of decision making. Let the whole world unite to take suitable measures and push up. Earth overshoot 5 to 10 days ahead every year. To get this day on 31st December within few decades. I will finish with the saying of two great persons. Mahatma Gandhi said, for self-discipline, earth provides enough to satisfy every man's need, but not every man's greed. And Robert Redford said, for giving top priority to the environment, environment should be put in the category of our national security. Defense of our resources is just as important as defense abroad. Otherwise, what is there to defend? Thank you very much. Thank you, sir.
Thank you, Sinha sir, for your valuable inaugural address on Only One Earth. Now I invite our honorable guest, Shri B. Srinivasa Reddy sir, Chairman of Indian Waterworks Association, to address the participants. Srinivasa Reddy sir.
No.
Hello, Armin. Sir, Renu Kumar sir. Renu Kumar sir, Secretary.
Dear participants, Srinivasa Reddy sir will be delivering the talk shortly. I appreciate your patience.
Madam, so if the sir is not there, I think you can request our Dr. CPS Prakash to deliver the presidential talk, please.
Okay, okay, sir.
You please.
Now I welcome our Honorable Principal, Dr. CPS Prakash sir, to propose presidential address.
Sir, is there anybody?
Prakash sir, over to you, sir.
I think as today several programs are going on in the college campus. Principal is attending other conference which is going on now. Anyway, he is going to deliver the presidential talk at the end of the day, maybe around 12:30, something like that. Now you can go to the technical talks. Madam, you can easily invite Dr. Yang sir, please. Dr. Yang sir, please. I think, yeah, please continue.
Dear participants,
Yeah.
now we are entering to the technical session, which is based on only one earth. So in this technical session, we have two eminent speakers, and each speaker will be given a time of 40 minutes for their presentation, followed by panel discussion along with questions and answers.
Let them
I would
take
like
more
to
time,
introduce-
no problem at all. Let them take more time, no problem.
Okay, sir. So, I would like to inform that no time limit for the speakers.
Yang is a very good speaker. We would like to listen to him.
Yes, sir. I would like to introduce the first speaker of today's technical session, Dr. Shu King Yong, Professor, University of Wollongong, Australia. Sir, Dr. Yong, sir,
Okay, thank you.
please start your presentation. Over to you.
Okay, thank you. Share screen. Can you see my screen?
Yes, sir. Yeah.
Okay.
Yes, sir.
Okay, thank you, Professor Nabanajo and Dr. Soyama for inviting me to attend this conference. My pleasure, highly appreciate. I remember a few years ago, very quick, 3 to 4 years ago, I visited your campus.
Yeah.
SDI was so beautiful. And very important impressed me is that very talented students and staff, very young staff. More important among the management, especially Professor Nabanajo, the leader, has very clear vision and know what is will be important for our human being. Then today I will talk about this one. And today I would like to give the talk. I'd like to share with you my thought in my mind. I like to introduce a technology called as SPP to protect the clean water in lakes. And this is what happened. You can observe it everywhere. And now I call this one water everywhere and not a drop to drink. This is a worldwide problem. I will show you. I come from University of Wollongong, Australia. I'm Shu Qing Yang, and I'm the secretary of ISCR. This is my email. You're welcome to send me email if you are interested and you want to continue with this talk. Early this year, I published a book. This is the book, Coast Reservoir Technology and Application. This talk about this reservoir in the ocean. And then I say, if in the future, every city in the world, if you can develop the number of fresh water from here to here, and then you will have clean city. Any city without the development of coast reservoir and fresh water, for the same problem, same place, they don't have, there will be the dry city. And also, this is for the coastal city. And visit your campus, I know where there's Bangalore, and I know this is the inland city. Today, I will talk about another topic, how to solve the water shortage problem in the inland area like Bangalore. And in this book, actually, I also talk about the SPP, and it is strategy can develop the flood water and also for the next zero pollution. And I shared with you the Typh Lake today and whatever. So today, my talk with water and people and water, and what pollution in lakes worldwide, and what is the SPP technology, how to solve Bangalore's water crisis, shortage problem. And finally, the conclusion. The first one, I would like to talk people and water. In my opinion, people, you and me are nothing, just water, because inside our body, 70% of the substance is water. So our body is water, nothing else. Not too much. Unable to understand your language, sir. Oh, sorry. I will try to speak slowly. This is the people, 70% of the people is made of water in our body. So you can see how important the water is. Not only the quantity, also the quality. Look at it from generation to generation. And human being come from trees, caves, and river, floodplains. Our shape and every day our size can be different, can be changed from generation to generation. But look at the eyes, look at the eyes, look at the eyes. It's the same. You are one, and then his one are the same. We are all looking for one thing, that is water. If you want to look at the footprint, you will understand why they come from trees, caves to floodplains. Just looking for the water, follow the water. This is why our civilization comes from bigger rivers. In India, Ganges River and Indus River. In the future, people all the way from this time come from the water and always near by the water. But our big problem today, we're talking about that one earth, our environment. We have the pollutants, and we know this will kill our people if the water quality is not good. So this is why I say people equal to movable water bag. You are not in movable water bag only. And water is different from other things. Only water can purify your body inside, outside, and also invisible. In Hindu, our soul can clarify. And different region, if you are sick, people will use the water to treat you the same. So this tells us how important the water for human being. But look at the world population will increase in this way. And then simultaneously our water usage increase in this way. Our water supply normally is constant. In India, your rainfall every year will be the same, never change. But our water demand increase and increase, the gap becomes higher and higher. How much water we have, where the water plant, but only small part, less than 1% of the total water is suitable for human being, so little. And the environment, the wasters intensify the water crisis. So this is why global water scarcity by 2025, 4 years later, 3 years later, and so many places will have water problems. And then by this year, India, that is Australia, the same. Now, 70% of the world population suffer at least 1 month of the water scarcity. water scarcity. In India, we not only have the water scarcity, or water quality also big problems. 70% of India's water is contaminated. India's worst one is your area. This is the water dispute between Karnataka and Tamil Nadu. Every year almost have the same thing. So Indian water crisis, we can say in this year, this Chennai didn't have enough water. 2020 and Bangalore list. 2030, 40% of India will have no access to drinking water. 2040, no drinking water available in almost all of India. This is only one water quantity problem. And also we have the water quality problem. So look at the water pollution in lakes. Hazardous worldwide every year. Last year, how much waste we produced? 50 million tons. 50 million tons of hazardous. Globally, 80% of the municipal wastewater is discharged into the water bodies untreated. The global growth, agriculture waste, pesticide, chemicals, fertilizer, all pollute our lakes water. In China, globally, so much percentage come from China, municipal. USA also. So this shows us the wastes we produced worldwide and in the future. This tells us our fertilizer and the pesticide will grow in this way. So this is a big problem for our water society. This is the wastewater warning every year produced the Asia increase in this way. Sure, definitely. Australia has the same problem, but Australia's population is very small. This is why we say water everywhere, but not a drop to drink. That is, people suffer the water problems, but the water quality is not good enough, are waiting for the sky water. Every year, 1.5 million children die every year from water quality problems. This is that how many people die per so many people because of the water pollution. India very high. Australia, the size, the number is smaller. Water quality problem not only happened in developing country, even developed country also. This is what happened in USA in this period. It is Great Lakes, this city. The wastewater killed at least 12 people. That's the water from this polluted lake water. And President Obama openly says sorry to the people in the TV. Also, this happened in China, a city of the Wuxi, Taifu Lake, one of the largest lake near Shanghai. This is the lake water, algal blooms, this color, and then no water supply to this city. So it is Prime Minister, this Prime Minister came to here to say sorry to the people. Same, Bangalore, city of the burning lakes, experts says Bangalore will be this way. by this year. So can we solve this problem? And look at the SDG in India. We have so many people had the drought problem, not enough water. And also 1/5 of children deaths are because of the water quality. Every year, so many people. Can we save our children? This big question. So now let me talk about that. We know that our question is bigger. And now let's talk about SPP. What is SPP? In my book, published this year, I said in this way, to solve any problem caused by the invasion of dangerous or hazardous substance, one must identify the most important factor. Then this variable or factor should be divided or separated into two parts, wanted or unwanted, good or bad. The wanted part should protect, and measures should be taken to prevent the mixture of unwanted and wanted part. The SPP stands for separation of good quality water from the poor quality water, and then protect the high quality water and prevent the mixing of pollutions. For example, this is imagine this is a lake. We have many incoming rivers. We also have the outgoing rivers. Currently, we just let them mix together. Clean water and polluted water mixed together. So finally, you observe that in USA, in China, in your city, all the water a big problem for us. In the future, we should have a sensor to monitor incoming flow. We should have the dike here. And then we have the gate. If your incoming water quality is good enough, I open the gate so the high quality water come to the center for storage. If the quality not good enough, I will close the gate, and then your poor quality water will be discharged to downstream to the ocean from the rivers. So this is the things we proposed. Okay, we can see in the water, in other area, not the water, we already applied the SPP technology. For example, in Bangalore, if you drive your home here, your university here, and then you drive your car, probably you have to drive from here without go to the city directly. This means we already use the separation. We separate your vehicle plate. We know you are not the residents. You are not the people living here. Your car is not registered from here. So you use this way, come to your university, so that we can solve the city traffic jams problem. But we didn't apply this one for our city lake's water quality. This one we use this way. We call it as a lean law to protect our local space, protect the city road space, prevent the mixture of the external car with the local cars. This is what is we want to promote. We want to use the same strategy for our water quality management. Another one is the spongy city. This happened in China, in Australia, everywhere, every year. Big stones. But recently in China, the people found a city called as Ganzhou, constructed the city 800 years ago. In 800 years, they never had the flood problem. And then the experts start to investigate why, what we can learn from the older generation people. Maybe this one happened also in India, older cities, very smart planner that the current generation in India should learn from that. Because this city is surrounded by rivers, and then the city's river also discharged to the ocean. Actually, they use the same idea to separate the city from outside flood water. If the outside flood water is high enough, they close the gate here. So here the water, where outside the water never come to the city area. So this one protect the city. In this case, they separate the water by it is water level. If your water level is higher than the city's water, and then this one, no water can come to the city. Otherwise, the water, if lower, and then the water come to the outside the river. Separated and protect the local people without the flood, and prevent the mixture of outside water with your inside water. Prevent the mixture. Is the very good one. Actually, the idea the same SPP. And this is the Baghdad city, Iraq. Many years ago, they also used the same way SPP for the city. In this case, in the war, they separated by the people's identity. They will try use this one to protect the people and prevent the mixture of external people and also the local people. The COVID-19, China used the zero COVID-19 strategy. That strategy actually is also SPP. The separation by virus. You test whether you have the virus or not. If you have the virus, sorry, you are not allowed to go to this people area. They want to protect the people inside China. And then they prevent the mixture of the infected people and healthy people. This happened in China. Actually, every country, every city, every campus, every university should use SPP to protect your student. So what's our proposal for USA, Canada, for the good neighbors? And then simply we say we should construct the dike inside the lake. We should have the gate. The gate is yellow color. We should have the sensor to measure your incoming water. If the quality is good enough, we open this gate so that the clean water can store inside the lake. Otherwise, the poor quality water will go through the bypass channel, go to downstream, come to here, go to the ocean. So we use the SPP, the same idea like Bangalore's Ring Road. You are not qualified to the center. You should go the Nimrod. So my center part is only for people, for the water, high quality water. And this is one about the Taff Lake I showed you before. Taff Lake, 80% to 90% of the pollutants come from here. And we only need to construct a dike inside the lake, and we should install the sensor here to monitor your incoming water quality. If the water quality not good enough, we should divert the water to downstream through this river to the ocean, and we can solve this problem. And this is, if you look at here, this is the Dianshan Lake, the water source for Shanghai many years ago, but now the water quality, like Bangalore's lake, water quality too poor. And I analyzed this lake's water quality, and then the lake, the incoming water from here, outgoing water from here to here. I say you should close this one, close here, and have the gate here, and construct the dike here. And make sure the incoming water, if the water quality good enough, I open the gate here and let the high quality water come in to store inside the lake. And actually here, this station and this station's measurement from 2011, 2012, 2013 are high quality already, class 2 to class 3. And the incoming water S1, sometimes high quality, class 2, sometimes okay, sometimes worse, sometimes very bad and very, very bad, class 1 to class 5 and class 5 plus, means the water quality is good for human beings drinking purpose, class 2 and class 3, and it can be used for agriculture, class 4, industrial, class 5, can be used for any purpose, class 5 plus. But you can see the incoming water sometimes not good enough, not always, only happened in this year. And every year we only have 1 or 2 times it is water quality is poor, incoming water. So in that period, we should close here, close here, close here, close here, and all this water should be diverted out of your river system, diverted to here, to the ocean, without storage. So if we use SPP strategy, we can quickly change the lake for the drinking water purpose. Okay, now finally I talk about the Bangalore's water solution. Generally, around 80% of India's water is polluted because you know the reason. This is the big lakes. All the lakes, we can use SPP and then to improve its water quality. And the world's 12 most water stressed city, one of them is this one, Bangalore. And your media in this year predict why Bangalore may run out of drinking water in 12 years, very soon. So we should answer whether India run out of water or not. I believe Ganges, Gandhi's word is very smart. I fully believe there is sufficiency in the water for man's need, but not for man's greed. We have enough water for Bangalore. We should manage it in a smart way. Our clean water is blue gold. We should not allow the blue gold to be mixed, polluted by the wastewater, by the polluted water, poor quality water. So this is my suggestion to strategy to Bangalore and Karnataka. Karnataka and Tamil Nadu had the water agreement to divide the water. Every year, Tamil Nadu gets so much water and Karnataka gets so little water. This is why you don't have enough water. So my suggestion in my book is Karnataka should help Tamil Nadu to construct the coast reservoirs here. Look at this year and 1 month, so much water was discharged to the ocean. This is water resources also. We should use this water resources, use this coast reservoirs to store the high quality water. So Tamil Nadu will have enough water to meet that demand. In that case, because Karnataka helped them develop this coast reservoirs, and then Tamil Nadu people will say, thank you, brother. Now I have enough water. You can use more water as much as you want. Tamil Nadu will say so, for sure. So our problem is whether they want to give you so much water for you to use, whether you have the water storage or not. So we say in this case, Karnataka and especially Bangalore, your most important one is to have big water storage. Tamil Nadu will allow you to store, no problem, to develop the water resources. So this is what I want to promote the idea. Try to build the dike inside your lake and then have the gate and a sensor to measure the water quality. High quality water coming to the center for storage. Poor quality water bypass your lake, go to the downstream. We should use this strategy. This is the water source for Bangalore city. And now your water comes from here, water comes from here, and for the city. In the future, once we have coast reservoirs for Tamil Nadu, and then you will get the more water. The government, Tamil Nadu government will allow you to store more water. You should solve the problem of the storage shortage problem. And in that case, you can consider this area to develop this area for water storage to meet your future water demand. Also, this is your lakes, so many lakes. Every lake you can use SPP to develop it as a water storage, drinking water storage. I take this lake as one example. This is the largest lake in your city. It is area 3.6 kilometers square. Its catchment is 150 kilometers square. Average depth 9.2 meter, storage capacity 500,000 meter cube. So in that case, we should have the dike inside the lake. We should have the sensor to measure the incoming water quality. If the incoming water quality is good enough, I open this one. And then, so the clean water can be stored in the center. Otherwise, poor quality water, I will close the gate. So the poor quality water will bypass the lake, go to the downstream, whatever. So this is one example. So we set up the ISCR, and our mission is to supply sufficient high quality and affordable water to the world, including Bangalore, with the minimum environmental and social impacts. ISCR is unique, it's different from other associations and groups. Other people always say, Bangalore, you don't have enough water. Only ISCR says you have sufficient water for your need. We follow Gandhi's teaching. Other people says, flood water, your flood water every year you have, and none of just run to the ocean and the sea without, that is not water resources. We say your flood water none of also is also water resources. Other people says water storage can be only located in the mountain area. We say inside your city also can develop as a water storage. Other people says if you want to solve Bangalore's water shortage problem, it is the consequences high and negative environmental and social impact. ISCR say we solve your problem with no and positive environmental social impact. Other people allow you to mix toxic water, chemical water, poor quality water with your clean water, rainwater, and we want to separate both of them. Other people feed the people with the artificial water from unknown sources, maybe your toilet to make it clean and make it ask you to drink. We are different. ISCR help people drink the natural water from the heaven directly. So I invite all of you join ISCR to save water, save the future. All of you are welcome to join. This is our inauguration, and this is our president from IIT Guwahati. This is the Professor Roger Faulkner, past president of IAHR Hydronics. This is past president of IWA, past president of Water Resources Association, and past president of Hydronics Association. All of these great leaders now already inside the ISCR to wait for you to join. We work together to solve our problems. Finally, I'd like to give the conclusion. The water is not only about the water. This Gandhi's teaching. Our water is not out of our rivers but polluted. This is our problem. Our water engineers should separate the two of them. Our water crisis is not caused by water shortage, but storage shortage. Clean water shortage in the lake is feasible. SPP stands for separation, protection, and prevention. SPP technology can supply sufficient high-quality water to inland cities like Bangalore. More detailed research is needed. This is after today's presentation, and then maybe tomorrow we can work together to do the research together. Among all the existing water solutions, only SPP technology for inland city is sustainable, which can accelerate the Indian century in the 21st century. Also, this is my prediction. I fully agree this one. In the 21st century will be the Indian century. So join ISCR to save our water for our kids. Thank you very much.
Sir, your inputs on SPP, separation, protection, and prevention technology to prevent clean water in lakes across globe and coastal reservoir technology and applications for the betterment of our planet is the need of the hour. Sir, your study indicated that Bangalore is one of the top cities globally to have severe water crisis. It's really worrying, sir. So
Yeah.
our policymakers should take immediate action to conserve our water bodies. Thank
We
you, sir.
should work
for telling-
together. We should work together and do some more research works to convince the government.
Yes, sir. You're right.
Yeah. Yeah.
So working
Stop.
together will definitely make a difference.
It is a very good talk. I have to congratulate Xue King Yang for accepting our request and delivering the talk. Sir, I wholeheartedly thank you for delivering a talk. Please keep in
Thank you.
touch. Please keep
Yeah,
in
yeah,
touch.
yeah.
with us.
Sure,
I-
sure,
I-
definitely.
1 minute, please. I request all the members, even the students, members, and the participants, just open your videos. We'll have a photograph along with Yang sir, please. I request all the members to, I request all the others also, where please open your videos. We'll have a photograph, please. All the participants are requested to open their videos to have a photograph along with our respected Xue King Yang from Australia, from University of Lango. All the
Thank
members
you.
are
Over
requested,
here.
participants are requested to open their videos, please. Keep. Sorry.
Thank you, Dr. Yong, sir,
Thank you.
for delivering wonderful presentation. So now I invite, shall we move on to the next
Yeah.
speaker?
Madam, principal is may come at the end. He told once the madam talk is completed, after it is over, we can easily request the principal sub and Srinivas Reddy sub also is also agreed to join with us at the end.
Okay, okay, sir.
Now it is left to Dr. Leena. Madam, it is in your court now. You can use the time as you wish. Definitely, you can go ahead.
Sir, I want to introduce Leena
Yeah, please.
to the audience, sir. Leena, just give me 2 minutes. I want to introduce you.
Thank you.
It's my privilege to introduce Dr. Leena Shevde for 2 reasons. First, she is one of my good friends and we worked together for about 2 years in this esteemed institution before she shifted to US. And the other reason is I'm introducing Dr. Leena to the audience in this platform. Leena, I wholeheartedly welcome you for this technical session. Please start your presentation.
Thank you. Thank you, Soumya.
You're welcome.
I hope I'm audible and I just shared my screen and everybody can see my screen, right?
Yes, you're
Okay.
audible and we could able to see the screen.
Great. So, first of all, thank you very much for inviting me, for having me here. And I am going to talk about climate resilience and sustainability. As very appropriately introduced, like today's session by Dr. Sinha, and he talked about the 1972 Stockholm Conference, and this year we have the same theme. And it's really important to reflect back on what we started several years ago. So before I jump into the actual climate resilience and sustainability, I want to introduce myself and what I did before I started teaching. So I worked in industry for a couple of years and various infrastructure projects. So the dam here that we see is one of my very first project that I worked on as a fresh engineer, and I worked on the construction management of that project. So many of you are civil engineers and looking forward to work on that. And many of you are also like water resources engineers and look at various different aspects of it. So we all know, many such dam projects are constructed in India and all over the world for several reasons. And this particular dam on which I worked on in my initial years gave me an insight of why I wanted to move to environmental engineering. The most important part was the environmental impacts of what infrastructure we create. And then I moved to academics and started working as a professor as well as a researcher. My research mainly focuses on the sustainable, resilient, and smart integrated water resource management structures and monitoring and modeling of them. I teach various courses such as Envisioning a Sustainable World, Introduction to Environmental Engineering and Studies, Hydrology, Fluid Mechanics, Water Resources, as well as some of the basic introductory courses such as Introduction to Engineering and Strength of Material. I absolutely love teaching and my research as well. So again, it's my pleasure to talk with you all. At any point, feel free to ask any question. At the end, we obviously will have a question and answer session, but just don't mind my hoarse voice right now because it's almost 2:30 a.m. here. Okay. So my talk will be, excuse me, can you please mute yourself? Yeah, thank you. So first of all, I want to start my talk with difference between climate and weather. Most of you must be aware of this, but I just, I like to start with that, and then we will move to the climate change and some of the indicators that we use. Then I'm going to introduce the Sustainable Development Goals, and then we'll move to how do we measure sustainability. And I want to discuss some of the climate action plans and sustainability efforts for some of the cities in the world, especially San Francisco, Bangalore, New York City, and Easton. Okay, so let's get started. These are part of my motivation, how I started working on green infrastructure, or what made me interested in designing the sustainable and resilient water infrastructure. So some of you might have experienced this Mumbai precipitation 2005, and this is one of the flood that I personally experienced, and I was stuck in my office for 2 complete days. Luckily, I was safe. I have, we had access to water and food, but not everybody were safe, and they couldn't, some of us couldn't make it. The picture on the right shows the New York City in 2012 during Hurricane Sandy. And these are not just 2 standalone things, or not something that only I have experienced. You all must have experienced similar floods, and these are not just one, but day by day they are increasing. The common theme here is both Mumbai and New York City. These are coastal cities. I'm born and brought up in Mumbai, and then I worked in both cities like Mumbai and New York City. These both are coastal cities that has high precipitation. These both are economic hubs. These are home to diverse populations. And both of them have proactive municipalities. So if we look at, like, we have all right environment to have the sustainable planning as well as implementation. So what do they really indicate? They indicate climate change, increase in flood frequency, increase in intensity of floods, and it just indicates it's real. Climate change is real. It is happening. It is happening right now. And let's not waste any time debating about it. So what can we do about that? So before we move to how do we solve this problem, let's understand what is the difference between weather and climate. So weather is short-term state of atmosphere. Okay, so today it could be sunny, it could be rainy, there could be thunderstorms, right? The climate is the long-term pattern of weather. Tropical climate, right? India, especially like the coastal cities there in India, we are closer to equator, they have tropical climate. Right now I'm in Northeast America, where it's subtropical to climate. Okay, so what we see year after year, so average weather over many, many, many years, that's what is the climate versus the daily fluctuation of temperature and precipitation, that's what is weather. Now I'm going to talk about some of the climate change evidence, and we will use some of the indicators. The most commonly used indicator is the carbon dioxide, concentration of carbon dioxide in the atmosphere. So most of you must have came across this. So on our x-axis, we have the time, and on our y-axis, we have the carbon dioxide concentration in parts per million. Years after years, what we have seen is kind of stationary or fluctuations within a range of our carbon dioxide in our atmosphere. But then right after 1800s or late 1800s to early 1900s, that's where we started the industrial era. And that's when we see this hockey stick, right? Right there, we start sudden increase in the carbon dioxide concentration, and it's not in our normal range. So 150 to 300 is our normal range. That's the fluctuation. That's the natural fluctuation that we have observed years after years after years. And this clearly indicates, it clearly matches with the industrial era. So what are the consequences? So the second indicator is melting of sea caps. This picture here shows the square, red square, or the red square shows the ice cap. We can see in 1980 or in 1979, we can clearly see here that the ice cap was larger than the ice cap what we have right now, or around 2015. Another indicator is melting of glaciers. The figure here shows the average cumulative mass balance of reference glacier worldwide, starting from 1945 till all the way 2015. And we can clearly see that these glaciers are melting. Next indicator is the increase in flooding. So I'm just showing from United States, but if we plot a graph for entire world, then we will see very similar pattern. So these orange, okay, the orange marks are from 1950s, whereas the 2010 are the purple ones, and we can see the number of flood days have been significantly increased for most of the coastal region, but also for some of the interior part. So the next one, which is very important for us, like especially for Asia and for India, is the droughts, the frequency and intensity of droughts. So even if half of the United States suffered from severe drought, and this index is comparatively new, and the value can be close to zero if the rest of the country was wetter than the average. So, it's not necessary that this, like when we average out, the change that we want to see might not be visible. But what we see here in this picture is the droughts are becoming more severe. And in some of the areas, while other places receive more rain as a result of climate change. So we want to be ready for both droughts as well as for floods. So I just want to summarize what we discussed so far. We are responsible for climate change as human. This is clearly anthropological change. The normal range, the middle three graphs are the normal ranges, the volcanic activity, the internal variability, and the solar component is marked by that purple rectangle, which is within a range, and that has not changed over several years. What has changed in last few years? We can clearly see.
ಹೆಲ್ಪ್ ಮಾಡ್ತಾ ಇರ್ತೀವಲ್ಲ ಅಪ್ಪಿ ತಪ್ಪ ಸಿಗ್ತೀವಲ್ಲ ನಮಗ್ ಬೈತಾ ಇರ್ತಾರ ಅಷ್ಟೇ ಫ್ರೆಂಡ್ಸ್ ಅಂತ ಮಾಡ್ತಾರೆ.
Excuse me. So what really has changed is the anthropological activities, and because of that the global temperature has increased. So we need to work together to fix this problem, right? Let's accept it, let's own it, and let's fix it. Will we observe similar climate change impacts globally? The answer is no, right? For Asia, as we said, the problems are severe, they're more. So what we see here, these are the risk factors. So we will have like increased risk of crop failure and lower crop production. That could lead to the food insecurity. The drivers are increase in temperature, increase in high intense rainfalls. And the problem, the risks are high. Water storage in arid areas of Asia. And again, we can see this problem is medium to very high. Some of the areas will face the more water shortage, whereas some of the area might have medium. The risk of increased risk of heat-related mortality is also higher. The risk of water and vector-borne diseases is also getting higher these days. And now I'm trying to show the North America, the same risks. And what we see here is the climatic drivers. Again, they are like temperature, extreme temperatures, and the extreme precipitation. And what we see here, in very few areas, they will be like very high or intense, right? So Asia, we will have to, the problems related to climate change are higher, and we need to act on it, right? So what can happen because of the increase in temperature, or increase in the extreme heat, or cold spells, frosting, right? So these are, so on the y-axis, we have various different impacts, and on the x-axis, we have various indicators. So air pollution, atmospheric carbon dioxide, radiation at the surface, these are all various different categories. And on y-axis, we had different consequences. The risk levels are shown here. The reddish ones are very, very high. The maroon is the highest, or is significantly higher than all others, right? So we can see the heat related or the temperature related consequences are really higher, and that can affect our food security as well as water availability. It will obviously impact the ecosystem. So what do we do? How do we approach this? So what we have to see is the environmental and institutional context. We want to also look at the social and behavioral context. We want to, when we are looking at the climate impacts, they're not just standalone, they're not just technical problems, but they are also associated with the economical problem and the social problems. The exposure related to extreme heat, poor air quality, reduced food will impact people differently. And we will have the impact of environment, impact of change in the climate on people differently. The health outcomes will also change. So how do we address these issues? So this is the representation of sustainable circle, or how the 4 pillars of sustainability: economics, ecology, or the environment, culture, or the social aspect. So some people like to combine that. We can call that as EEE or PPP, where we just say people, profit, and planet. And sometimes we like to differentiate the cultural aspect apart from the politics going on within the society. So these are our pillars of sustainability. Some of the sustainable development goals, and now we have the SDG 13 is the climate action goal. We have other problems that are directly or indirectly related to the climate action, but we cannot keep them like separate or just by standalone by themselves, right? These are all intertwined. So how do we, what is the solution? How do we tackle this problem or address this issue? So climate change, whenever we talk about climate change, we talk about 2 aspects. One is the mitigation, and other is the adaptation. I like to talk about mitigation more because I have more hopes and I still feel we can reverse it. So the goal of mitigation is to avoid significant human interference with the climate system and stabilize the greenhouse gas levels in the time frame sufficient to allow the ecosystem to adapt naturally to the climate change. We want to ensure that our food production is not threatened and we are able to survive and sustain the economic development to proceed in a sustainable manner. So what do we need to do for that? So we need to cut down on our fossil fuels, especially for electricity, for heating, for transportation. And we have the alternatives. So we have lots of solar power. We also at places we can have wind power. We need to certainly, especially in US, we need to reduce our consumption. And that is the trend, that newly started trend in India as well, right? So we certainly need to cut down or reduce our consumption. We need to enhance the sinks. So what can absorb the carbon dioxide, such as the oceans or the forest and the soils, the trees obviously will absorb. So we want to increase those. Even though we say like, I'm very hopeful and I'm very positive about like, if we take the right action at the right time, we can reverse the climate change in the positive direction. We still have to, we have done the damage and we still have to talk about the adaptation. How do we, there are like consequences and we are already seeing some of the consequences. And how do we adapt to that? How do we change? How do we design our structures? So the goal of adaptation is to reduce the harmful effect of the climate change. For example, the seawater level and encroachment, more intense extreme weather events, or the food security. It also talks about the adapting our new life, like for the changing climate. That involves adjusting to the actual or expected future climate. So now, how do we, like, we know these are the consequences, like, and some of you might have heard about most of the stuff, but how do we measure these and how do we track sustainability efforts and our climate action? Is it sufficient? Where are we, like, how much have we done so far? And how far do we have to go? Excuse me. So STARS is one of these. So I'm going to talk about two important factors. STARS is the Sustainability Tracking Assessment and Rating System. And the other one is the Leadership in Energy and Environmental Design. Excuse me. Can you please mute yourself? A transparent, so the STARS program is the Sustainability Tracking and Assessment Program, and this is specifically for the colleges and universities. This is a self-reporting and transparent framework that measures the sustainability performance, and this is like globally. Any university or college can track their own sustainability efforts. The required areas for this are, like, first of all, the curriculum, what we teach, what do we include in our courses. Then our research, research related to sustainability. our campus engagement, our public engagement? How do we help our society to be informed about climate change and the action of what actions are we taking for that? Are we communicating? Are we helping the society to understand the climate change and the sustainability efforts? Then air and climate, the buildings are important part. Do we have sustainable designs of our campuses? Are we using renewable energy sources? What about our food? Are we producing food on our campus? Do we have sustainable dining solutions or sustainable dining practices? And a number of things listed here, right? Social aspect, well-being, work ethics, coordination and planning, and many more. And the STAR program, it's self-reporting framework. So we report it on our own. So the next one, so one of such example is from New York City, New York University. And we can see the green ones are the emissions per student, and the red ones, the bar in red, they show the emissions per 1,000 square foot. And some of the comparable universities in US are listed here. So the New York University presented this case study. So they are the one in the red mark here, and then the rest of the universities are listed here. Another certification that some of you might have come across is the LEEDs, and LEEDs is the energy rating system. But it's just not energy rating. It also considers water usage as well as in general, the sustainability. So the walkway, the designs, what type of material are we using, and many other aspects. So with that, now I'm going to discuss some of the climate action plans and sustainability efforts for a few cities. So one of the cities is San Francisco, who has taken efforts long back, like starting like very early. Since 2004, San Francisco have developed their own climate action plan. And what we see from 1990 to now, which is like in last almost 20 years, you can say now, the emissions have gone down by 41%. The GDP has grown by almost 200%, whereas their population has increased by 22%. And what is their roadmap forward? They want to get all their transportation on renewables, on the renewable energy by 2030. They want to be zero waste town or zero waste city by 2030 as well. Right now, all the buildings, like by 2021, that was their goal. All the buildings, they wanted to be fossil fuel free buildings. And by 2040, they wanted all their commercial buildings to be fossil free. By 2025, they wanted to have 100% renewable energy, the transportation by 2030, and then they want to build new 5,000 houses. So what are some of the challenges that San Francisco face? They have extreme heat days, around 4 days, what they have observed earlier. And now that is increased from 4 to almost like 12 days, and so on. Those are their projections. So what we expect in next 30 years is like, it's not just 4 days, which is like historically observed, but now the projections will be like around 12 days or 28 days. The maximum length of the dry spell, so when there won't be any rain in between, are like 111 days. That's have been like historical pattern, but the projected is 118 to 153. Maximum one-day precipitation, historically what we had observed was 1.69 inches, whereas we are projecting 1.81 inches, or like with the other projection, it can go up to 2.3 inches. And the seawater level is expected to rise by 66%. So what do we do about it? So we want to be responsible in our production as well as in consumption. So the goal is by 2030, San Francisco want to reduce their solid waste generation by 15% below 2015 levels. They also want to reduce their disposal to landfill by 50% below 2015 levels. For the transportation and land use, by 2030, 80% of the trips taken by low carbon models. And same way for energy supply, San Francisco wants to be 100% on renewable by 2025. Healthy ecosystems, they want to sequester residual emissions through the nature-based solutions. Mostly in San Francisco, they're managing their stormwater using green infrastructure now. So that's a win-win. We are not creating any additional gray infrastructure, and we are also adding the forest, not really the forest, but the trees into the urban ecosystem. Housing, they wanted to build 5,000 new houses and no less than 30% affordable. So affordable housing is one of the important sustainability criteria. So that was about San Francisco, and each and every city will have different key problems that we will try to solve, and it will change differently. So the New York City has the design guidelines. California has their own critical infrastructure plan. We also have very similar sustainability plan for Bangalore. And one of the important factor in Bangalore is water supply. Okay, so with that, I'm going to move to Easton. And Easton is a small town in Pennsylvania, United States. Lafayette College is one of the important part of Easton, and the Crayola factory is another thing, which is the industry. And Easton also had industry from the beginning. So there are plenty of, and the industry has moved out of the town, but we still have the brown fields, and it's a historical town. So that's a little bit background about Easton. It's on the confluence of Lehigh River and Delaware River, as well as the Bushkill Creek. So whatever, this is kind of last point getting into the Delaware River. So whatever action Easton does, it kind of And Delaware River provides water to not just to eastern area, but also to the other important cities around. So the water quality is important aspect here in Eastern that we want to address. So these are some of the key points, and this work was again done by some of my students. So they interviewed some of the stakeholders in the city, and they identified these 11 different problems or important criteria that Eastern stakeholders wanted to address sustainably. So whenever now Eastern is designing their infrastructure, they want to make sure that these problems are addressed sustainably. So they want to increase the walkability. They want to reduce the solid waste. They want to increase the recycling in the area. They also want to address the traffic issue in the neighborhood. They want to address the water quality. They want to reduce the crime rates. The vacant properties, which are the brown fields of the old industry has moved out, but that land is there. So instead of now taking down new agriculture field to build the housing, what we can do is develop these brown fields. Then code and enforcement, economic development, neighborhood pride, and safety. Also, Lafayette is one of major partner for the Eastern city. So the interaction of Lafayette community, that is the student, faculty, and the staff with Eastern community, their interaction is also very important in developing Eastern. So how do we improve sustainability? So some of the options are like how to improve the food sustainability. We need to source our food locally. We have to produce it locally. And this is the La Farm. So all the students and the faculty members, they produce the food, and many of the dining halls receive food from La Farm on the campus. But during summer, when all the students are out, the farm still produces, and that's when most of this food is given to the local pantries, where it is received by the local NGOs for distribution. We want to select, whenever we are building new things, we want to select our material and technology. We want to make the smart choices. The green roofs, they are different from the traditional stone ballasted roofs. And we want to look at the life cycle stages of it before we take any decision. So we just don't, we want to base it off not just the economical value, but also what are the long-term impact of that. Can we get the material locally? So when we are selecting the material, can we source it? Can we use the recycled aggregates for concrete? Can we use the other material? When we are designing new infrastructure, we want to make sure that everything is within 15 minutes. It's walkable. And we have the bike lanes, we have the walkways, we have more interaction with our community. With that, I'm going to stop right here, and thank you so much. If you have any questions, please let me know.
It was a wonderful talk, Dr. Leena. So your presentation on sustainability, resilience, smart and integrated water resource management, then US EPA regulations to tackle climate change, and action plans, sustainable climate action plans for major cities of US was very interesting, and it is appreciable. Thank you, Leena, for delivering a wonderful presentation.
Thank you,
My
Lina, for
pleasure.
delivering a very good talk. It covers the entire world. In fact, starting from Bangalore to even to all the parts of the world where you have carried out some of the literature and other works, what they have carried out. It is a wonderful work, and where you have done a lot of literature also, which you have collected the data and all. We have to thank you a lot for delivering a good talk. Okay, thank you, madam. Thank you. Thank you for accepting our request and delivering a talk. Okay, please keep in touch. And I think I can remember last week, when we had a in the some of the letter you mentioned that let us go for some collaborative project work and all. You please just mail it to me. Definitely will.
Sure.
Yeah.
Yeah, my pleasure. Thank you so much. Thank you for
Just
having me.
highlight certain things in the next mail so that I can easily sit on that. At that time, you just asked me because of some other busy schedules, just I forgot it. Please remind me once again if you send me all the details. Definitely, we are for it. We are ready to work because since you have come forward that too from that country, whatever the data is available, we'll try to gear up from our end also. We have the now good number of faculties and all. Definitely, we can work together for the other projects, assignments and all. Okay, thank you.
Sure. Yeah.
I
Thank
think
you.
over to Soumya only. I think she told that she's going to deliver a talk on air pollution because as Amrit Pol has already indicated, he has some health issues which he told yesterday only. Madam, I think you can just give the abstract overview of the air because water, its contamination, pollution, everything. Even Dr. Young and Dr. Leena Madam, they have already told so many things about that. Now I think you to throw a light on air pollution, please.
Okay. Yes. Okay, sir. Thank you, Leena. Have a nice day. Thank you.
Thanks, Soumya.
Sorry, it is a midnight. No, sorry for disturbing. Now you can go to take rest. No problem. No, please. Sorry.
Thank you. Thank you.
Thank you for your valuable time. Thank you, Lord.
See you, Leena. See you.
Bye.
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 Just a moment, sir. I'm going to share my slides.
ಎಷ್ಟು ನಿಮಿಷ ಅಂತ ಹೇಳ I think, madam, you can take another 15-20 minutes just for overview of the picture you can give, so that by 12:30, 12:40 onwards, we'll go ahead for our we'll request for Dr. Principal, CPS, and our Srinivas Reddy sir. They may throw a light on certain issues. Okay. You can start up. No problem.
Okay. Good afternoon, participants. Today, it's my privilege to deliver a talk on a part of my research work, that is intra-annual and intra-seasonal variability of PM 2.5 and 10 in Bangalore urban area. So my research work mainly concentrated on these sampling stations, Peenya Industrial Area, Saregunavahadli City Railway Station, BTM, and BWSSB. So we have collected the data, air pollution data from residential, commercial, and the industrial areas. And these are the observations my study indicated. This graph shows the variations of PM 2.5 and PM 10 in the study area. And you can see here, the x-axis, the months of the year has been plotted, and in the y-axis, the PM 2.5 and PM 10. So in Bangalore, the particulate matters concentrations are exceeding all the national and international standards. So we have compared it with national ambient air quality standards, US EPA, then European standards, WHO. Unfortunately, PM 2.5 and PM 10 concentration has surpassed all the national and international standards, and it is worrying as well. And if you can see in this graph, during post-monsoon season, during the month of September, October, November, and December, the concentrations of PM 2.5 and PM 10 are very high. So for that, my study also investigated and indicated that this increase in concentration is mainly due to the boundary layer height. See, always the air pollution and meteorological parameters, they go, so they're like the two faces of the same coin. So these pollutants, they are mainly dependent on the meteorological parameters. So during post-monsoon season, what we observed was the wind speed was very less. The air remained almost stagnant. That triggered to the increased concentration of PM 2.5 and 10 in the Bangalore atmosphere. And if you can see during monsoon season, the concentration is less. This is mainly due to the wet deposition we call, or due to the washout effect, the concentration has been reduced. And again, during January, February, that is during winter season, the concentrations are high. And if you can see in the graph, for the month March, April, and May, again, there is a decrease in concentration. So during summer season, the boundary layer height, the planetary boundary layer or boundary layer height, it appears to be high. So that triggers to the dispersion of the pollutants, and thereby the concentration appears to be less below the troposphere. So it is the distribution of PM 2.5 and PM 10 across the Bangalore region. And this plot also, this is the box and whisker plot we plotted to show the variations of PM 2.5 and PM 10 in the Bangalore urban area. And if you can see here, I've used the WHO standards and National Ambient Air Quality Standards, Indian standards. So the red dotted line indicates our Indian air quality standards, and the blue dotted line indicates WHO standards. See, the WHO standards are pretty lower value when compared to National Ambient Air Quality Standards. And if you can see this box, this rectangle, it has a tail. See, the tip of the tail, it indicates the 95 percentile of PM 2.5. And the color itself, the red color, it indicates the variations of PM 2.5 in BTM layout. BTM layout, it is a mixture of, it is the residential, commercial, and some of the industries, small scale industries are also noticed in the BTM layout. And the other stations are also marked there with respect to the colors. And if you can see these stations, when we compare these stations with the standards, see, all the standards, all the sample stations are surpassing the WHO standards. See, the blue dotted line is WHO standards, and some of the around 70% of the PM 2.5 concentration is within the permissible limit of National Ambient Air Quality Standards. So it is always, you know, what we do is Indian standards, we always set a higher value, and we say that we are maintaining our air quality is within the permissible limit. See, when we compare our standards, Indian standards and WHO standards. WHO standards are pretty lower value when compared to our value. So why can't we keep WHO standards, and why can't we focus to reduce the pollutants to that standard? So definitely it is challenging. And when we come to PM10 also, so City Railway Station is surpassing all the national and international standards. The yellow box in Risker plot, it shows the City Railway Station. And I think you all know that City Railway Station, the Bangalore City Railway Station, is one of the second biggest railway station in South India. So even it has a high concentration of PM10 in the atmosphere. And this graph shows the diurnal variations, that is the daily variations of PM 2.5 and PM 2.5 concentration. So the day wise. So when you see the hour wise, see the morning up to 6 o'clock, the concentration of PM 2.5 is less. So that indicates that no anthropogenic activities or no traffic is observed during this time. So up to 6 o'clock, so from early morning 12 a.m. to 6 a.m., the concentration of PM 2.5 is pretty low. So after that, after 6 a.m., the concentration starts increasing, and then it reaches maximum up to 10 o'clock. And you can see from 6 to 10, the vehicle transportation, the vehicle movement is high. So the PM 2.5 concentration is also high. And what we figured out is there is a direct link between the vehicles and the PM 2.5. As vehicle concentration or the volume increases, the PM 2.5 as well as PM 10 also increased. So they are the so the vehicles are the highest producers of the PM 2.5 and PM 10 into the atmosphere. And after that, after 10 o'clock, the PM 2.5 concentration decreases. So, and it becomes low, the concentration decreases till the morning, afternoon 3 o'clock, and again, the concentration increases. See, the factor why there is a decrease in concentration from 10 o'clock to 3 o'clock is, one is the traffic flow is less. So when we talk with respect to meteorological parameters, mainly boundary layer height. See, the boundary layer height appears to be high, appears to be more in the morning time, that is from 10 a.m. to evening 4 p.m. So that is also one of the reasons where the dispersion of pollutants are taking place with increase in boundary layer height, thereby decreasing in the PM 2.5 concentration. And again, after 4 p.m., definitely the boundary layer height starts decreasing, and the increase in the vehicles takes place, and the concentration increases, and so on. So this figure shows the diurnal variations of PM. It's not, the concentration doesn't remain same throughout the day. It varies hours of the day and days of the week. And also, if you can see here, this is the week of the day we have plotted, and during Sundays, this is the Sunday, during weekend, you can see there is a decrease in concentration of PM 2.5 when compared to the other days. That means the Peenya in Bangalore, the Peenya industrial area, so is one of the biggest contributors of air pollution. So even in Peenya industrial area, the PM 2.5 concentration during Sunday was less. So that clearly indicated that the industries in Peenya, so they were the biggest contributors of this PM 2.5. And due to the shutdown of those industries during the Sundays, the concentration was less. And this shows the PM10 concentration. It is just similar to PM2.5. See, both PM2.5 and 10, they have a high correlation value. That is, as PM2.5 increases, PM10 also increased. So, and our study also indicated that many of the sources are emitting both PM2.5 and PM10 into the atmosphere. And if you can look at the last graph, when compared to the weekdays, in the weekend, mainly on Sunday, the concentration appears to be less. That's mainly due to the shutdown of the industries, and also, you know, the holidays that has been declared. So across Bangalore, so many offices, schools, colleges, so remained closed during Sundays, and so that is the main reason for the decrease in concentration of PM2.5 during Sundays. And this is again, it is a box and whisker plot showing the variations of PM2.5 and 10 in various months across Bangalore. So during November, see, during November season, October, November, and December, there is a huge variation of PM2.5 and 10. So that's mainly due to it's not due to the emission factor, it's mainly due to the meteorological parameters. Meteorological parameters, we always call that as an independent variable. Nobody can control the temperature, variation in temperature, wind direction, humidity, or the boundary layer height. And these air pollutants, they are mainly dependent on this meteorological parameters. So the study mainly indicated this huge variation of air pollution during October, November, and December is mainly due to the meteorological parameters. So the meteorological parameters, it appears to be almost stagnant or very low. That resulted in accumulation of pollutants near the Earth's surface, that is below the troposphere. So this graph again shows the variations of the temperature and PM2.5. The red graph indicates the variations of temperature. You can see the temperature, see the diurnal variation of temperature is observed in this table. So in the morning, early morning, the temperature is less, and after 7 o'clock, the temperature increases. It reaches maximum at 12 o'clock. And if you see here, at high temperature, when temperature reached peak, the PM2.5 and PM10, they appear to be low. They appear to be very less. Why? Because both are inversely related. As I said before, the temperature is directly linked with the boundary layer height. As temperature increases, the boundary layer height increases. As boundary layer height increases, dispersion of pollutants takes place into the atmosphere, and thereby I request all the participants to keep your microphone in mute. So in this graph, as temperature increases, boundary, the PM2.5 and PM10 also that decreases. That means it is temperature. Temperature is one of the meteorological parameter. This temperature and the air pollutants are inversely related. So, and this scatter plot, this graph was plotted by using SPSS software, and it shows the correlation between PM2.5 and PM10. The correlation factor is a positive value, it is 0.37. That clearly indicates that the sources that are emitting PM2.5 are also emitting PM10. So both are positively correlated. So, and the last graph I'm going to see in this graph, it shows the seasonal variation of gaseous pollutants. See, compared to the particulate matters, the gaseous pollutants are within the permissible limit in Bangalore. So, except the ozone. Ozone, we call it as a secondary pollutant. It's a huge topic. It's very interesting. Ozone is not emitted from any sources. It is a secondary pollutant. It's the precursors for ozone are the methane, SO2, and non-methane hydrocarbons. And you can see the shape of the ozone curve. See, it is a bell-shaped curve, the ozone, and you can see as ozone in its concentration is increasing, the other gases are decreasing. That means they are chemically reacting to form the ozone. So these are the precursors for the ozone formation. So Bangalore atmosphere has high concentration of ozone. It is a secondary pollutant. How this can be tackled? How this can be reduced? It can be reduced only by controlling the emissions of these pollutants. So, and it also, the study also observed that during winter season, the ozone concentration was high when compared to other seasons. Even the particulate matters were also observed in high concentration during winter when compared to the other seasons. So, so the final, the output of the research work was the PM2.5 and PM10. So was surpassing all the national and international standards, and immediate attention has to be given to tackle the problem of PM2.5 and 10. So, and as well, the ozone concentration also, when compared to other cities. See, whenever we talk about the air pollution, so always Delhi will be in the limelight. So always Delhi experiences severe air pollution. So because of its weather conditions, mainly because of the weather conditions and also due to a stubble burning. Stubble burning in the neighboring states of the Delhi, mainly the Uttar Pradesh, Punjab, Haryana. So during winter season, they do stubble burning. So that is the main and the vehicles, they are the biggest contributors of air pollution in Delhi. So when compared to Delhi, the ozone concentration is in Bangalore is exceeding. We have a high concentration of ozone in the atmosphere when compared to the Delhi. So immediate the action has to be taken to reduce the ozone pollution. So since we have a time constraint, I could not discuss in detail this the particulate matters and air pollutants. So thanks for listening. So if you have any questions, you may ask. Sir? Sir, shall I continue or shall we move on to the next guest?
Madam, I have logged in.
Yes, sir. Renu Kumar, sir.
No, principal.
Oh, sorry, sir.
Okay.
Okay, sir.
Soumya?
Yes, sir.
You please request the sir to deliver the presentation.
Yes, sir.
Please.
Okay, sir.
Hello, madam. I will wait for my turn.
No, sir. Now, we are winding the program also.
Yes, sir.
At the urge of
so first, we will have the presidential address from you, and then we will take up the vote of thanks by Renu Kumar, sir. Is that fine, sir? Prakash sir?
Hello, madam. Shall I start?
Yes, sir. 1 second, sir.
Hello.
I request all of the participants to open their videos so that we can have the photograph, please. All the participants are requested to please keep the video open so that we can have a photograph, please.
Presentation stop, madam. Sharing.
Madam, you please stop your presentation.
Okay, sir. Okay, now I request our Honorable Principal, Dr. CPS Prakash sir, to propose a presidential address.
Yeah, good afternoon, all the participants and the invited guests, Dr. Ramraju, Professor and Head of the Department of Civil Engineering, and all the coordinators of today's event. I'm happy to be part of today's event. In fact, the theme is quite aptly selected. I hope you had a very fruitful interaction listening to the learned speakers. It makes us more responsible to be aware of the responsibility that we have got in protecting the environment so that we keep the place where we live, the world, a better place to live. And events like this will provide you opportunity to have reaffirmation into this kind of connect with the nature and society in building and also protecting the environment as a whole. I wish all of you a very active interaction in the days to come. This is a beginning, and we should continue to initiate a lot of activities in this direction so that in the days to come, we will be putting all our efforts in protecting the nature and saving the environment for a better tomorrow. I thank Head of the Department of Civil Engineering and all the coordinators for giving me an opportunity to be part of this eventful celebration. Once again, wishing you all the best. Thank you.
Thank you, Lord. Thank you, Lord. Sir, Renu Kumar is there, madam?
Thank you, sir. I thank Dr. CPS Prakash sir for proposing a presidential address. So now I invite K.S. Renukumar sir, Secretary IVA, to propose vote of thanks.
Sir, I am audible?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, Srinivas Reddy sir, whether he is coming or...
Sir, he told that Ashramdal Helidro. He told me I would like to enter and say, in fact, just now I gave the call also. He could not pick the call. That's why whatever the correspondence we had, I sent everything, but he has not seen the message also. He is busy with some of the devotees in the ashram.
Okay, okay.
Please.
Can I start my vote of thanks?
Yes, sir. Please.
Thank you. Good afternoon for all the dignitaries, students, and our friends. It's a really great pleasure to propose a vote of thanks on the occasion of International Virtual Conference to commemorate World Environmental Day 2002, which is hosted by Dayanand Sagar College of Engineering with Department of Civil Engineering, and also with Indian Waterworks Association Bangalore Center. So this Indian Waterworks Association Mumbai, which is our headquarters, was started in 1968, and our Bangalore Center was established in 1980. And in all we are having in the Bangalore Center, we are having our own building. I think which is unique in all IVA centers across the India, which is just completed that 4-story building in a record time of 10 months. And On this occasion, we want to thank our in-charge engineers who were at that time, especially our beloved President, Chairman Srinivas Reddy sir. So I thank Shri P.K. Sinha, President HIVA, for their cooperation to conduct this international virtual conference to commemorate World Water Day 2002 on slogan which is only one water. That itself indicates how important to save our only one earth. In this regard, I thank today's guest of honor, B. Srinivas Reddy, Chairman IVA Bangalore Center, who is somehow due to his busy schedule does not attended this event. But again, once again, I am grateful and thankful to him for giving all the wonderful cooperation for conducting this event. I thank Dr. Shu King Ang, Professor, University, Wollongong, Australia, making it convenient to deliver the valuable talk on SPP, a technology to protect a clean water in lakes, that too especially even with respect to our Belandur Lake of Bangalore. So that's why we are always grateful to you, sir. Thank you, sir. And I thank Dr. Amrit Paul S. Sago at School of Architecture and Environment, Nottingham, Trent University, UK. But somehow she is also not able to join this event. So in that place, our Professor Dr. Soumya, she has given a very good presentation on pollutants over urban area of Bangalore. That's really appreciable. So I think in this occasion, I request Madam to at least to join hand with our KSPCB officials, so that at least whatever little bit we can at least move forward in this direction. I thank Dr. Lena Shivade, Professor, Lafayette College, Pennsylvania, USA, making it convenient to deliver the valuable talk on designing sustainable stormwater green infrastructure for climate resiliency. Really, it was a very nice presentation, and I thank once again, ma'am. I thank Dr. CPS Prakash, Principal, Dayanand Sagar College of Engineering, making it convenient to deliver the presidential address even with his busy schedule. I thank Dr. H.K. Ramaraju, who is the pioneer in organizing like these events, even with my personal thanks you, sir, and for his team for smooth conduction of this event. I thank all the participants who attended this event. I thank one and all. At least we are eager to know further events, because such a beautiful event as conducted by Dr. our beloved sir, Dr. H.K. Ramaraju, sir. Thank you, sir.
Thanks. Thank you. Thanks.
Thank you, Renu Kumar sir, for proposing vote of thanks. Now we shall end the program with National Anthem. I request all the participants to raise from the seat for National Anthem.
Jana Gana Mana Adhinayaka Jaya He Bharat Bhagya Vidhata Punjab Sindh Gujarat Maratha Dravida Utkala Vanga Vindhya Himachala Yamuna Ganga Uchchala Jaladhi Taranga तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I once again thank everyone whose contributions has made the World Environment Day 2022 event a successful one. Let's all join our hands to make this planet a better place to live. Thank you all.
Thank you, ma'am.
Thank you all.
Thank you, sir.
We'll close the event. Thank you all. Thank you all for the cooperation.